From the moment humans looked up at the night sky, we've been fascinated by the stars. The twinkling lights in the vast expanse above have always sparked our curiosity and imagination. For centuries, we could only dream of reaching them. Ancient civilizations meticulously charted the stars, creating elaborate maps and constellations, and weaving myths and legends around them. Our journey into space began with simple rockets, used in fireworks in ancient China. These early experiments with propulsion were rudimentary, yet they laid the foundation for future advancements. These early rockets were basic, but they held the seeds of a future technology. Over time, rockets evolved, becoming more sophisticated and powerful. The principles of propulsion and aerodynamics were gradually understood and refined. They became more powerful, more sophisticated. Engineers and scientists worked tirelessly to improve rocket designs, pushing the boundaries of what was possible. In the early 20th century, pioneers like Konstantin Tsiolkovsky and Robert Goddard laid the groundwork for modern rocketry. Tsiolkovsky's theoretical work and Goddard's practical experiments were crucial in advancing our understanding of space travel. They developed the theory and engineering behind powerful rockets capable of reaching space. Their contributions were instrumental in transforming rocketry from a dream into a reality. Their work paved the way for the first human-made object to orbit Earth, Sputnik 1, launched by the Soviet Union in 1957. This historic event demonstrated the potential of space exploration. This event marked the beginning of the space age. The successful launch of Sputnik 1 ignited a global interest in space and set the stage for future exploration. The space race between the United States and the Soviet Union accelerated rocket development. Both nations invested heavily in space technology, leading to rapid advancements and numerous milestones. It led to incredible achievements. The competition drove innovation and resulted in significant progress in our ability to explore space. Humans landed on the moon. The Apollo 11 mission in 1969 was a monumental achievement, showcasing human ingenuity and determination. We sent probes to explore other planets. Missions like Voyager expanded our knowledge of the solar system, providing invaluable data and stunning images of distant worlds. Today, rockets are essential for space exploration. They are the backbone of our efforts to explore the cosmos, enabling us to send satellites, probes, and humans into space. They launch satellites that connect us globally. These satellites play a crucial role in communication, navigation, weather forecasting, and scientific research. They carry telescopes that unveil the secrets of the universe. Instruments like the Hubble Space Telescope have revolutionized our understanding of the cosmos, revealing the beauty and complexity of distant galaxies. Our journey into space is a testament to human ingenuity. The dedication and creativity of countless individuals have made space exploration possible. It's a story that continues to unfold. Each new mission builds on the achievements of the past, pushing the boundaries of what we can accomplish. As we push the boundaries of technology, we continue to reach further into the cosmos. The future holds exciting possibilities, from manned missions to Mars to the exploration of distant exoplanets. We are driven by a fundamental desire to explore the unknown. This innate curiosity propels us forward, inspiring us to seek out new frontiers and expand our understanding of the universe. To understand how rockets work, we need to grasp a fundamental law of physics, Newton's third law of motion. This law is not just a theoretical concept, but a practical principle that governs the mechanics of how we can propel objects into space. Simply put, this law states that for every action, there is an equal and opposite reaction. This means that any force exerted in one direction results in an equal force in the opposite direction. This principle is at the heart of rocket propulsion. Without it, the concept of launching a rocket into space would be impossible. Imagine a balloon filled with air. This simple example can help us understand the complex mechanics of rocket propulsion. When you let go of the balloon, the air rushes out. This is the action. The air escaping the balloon creates a force in one direction. The reaction is the balloon flying in the opposite direction. This is a direct application of Newton's third law. This is how rockets work, but on a much larger and more powerful scale. The principles remain the same, but the forces involved are exponentially greater. A rocket engine expels hot gas out of its nozzle at incredibly high speeds. These gases are the result of burning fuel inside the rocket. This expulsion is the action. The high-speed gases rushing out create a powerful force. The reaction is the rocket being propelled upwards, opposite to the direction of the exhaust. This upward movement is what allows rockets to break free from Earth's gravitational pull. The force that propels the rocket upwards is called thrust. Thrust must be greater than the force of gravity for the rocket to ascend. The faster and heavier the exhaust gases, the greater the thrust generated. This is why rocket engines are designed to expel gases at extremely high velocities. Engineers spend countless hours perfecting these designs to maximize efficiency and power. Newton's third law might seem simple, but it unlocks the incredible power of rocket propulsion, allowing us to overcome Earth's gravity and venture into space. This fundamental principle is the cornerstone of all space travel, enabling humanity to explore beyond our planet and reach for the stars. The rocket engine is the heart of any spacecraft. It's responsible for generating the immense power needed to escape Earth's gravitational pull. There are two main types of rocket engines: solid fuel and liquid fuel. Solid fuel rocket engines are the simpler of the two. They burn a mixture of solid fuel and oxidizer. This mixture is packed inside the engine's combustion chamber. Once ignited, the fuel burns rapidly, producing hot exhaust gases. Solid fuel rockets are powerful, but they lack control. Once ignited, they burn until all the fuel is consumed. Liquid fuel rocket engines are more complex but offer greater control. They use separate tanks to store liquid fuel and oxidizer. These liquids are pumped into a combustion chamber where they mix and ignite. Liquid fuel engines can be throttled, meaning their thrust can be adjusted. They can also be stopped and restarted, allowing for greater mission flexibility. The choice of engine depends on the specific requirements of the mission. Each type has its advantages and disadvantages. Launching a rocket into space is a complex process that requires meticulous planning, precision engineering, and seamless execution. To make this process more efficient and effective, rockets are often designed in stages, each with a specific function and purpose. Each stage is essentially a self-contained rocket with its own engine and fuel, designed to operate independently of the others. A multi-stage rocket works like a relay race, where each stage hands off the baton to the next, propelling the rocket further into space. The first stage, usually the largest and most powerful, lifts the rocket off the ground with immense thrust and energy. It carries the rocket through the thickest part of Earth's atmosphere, overcoming the greatest resistance and gravitational pull. Once the first stage expends its fuel, it detaches and falls back to Earth, reducing the weight of the rocket significantly. The second stage then ignites, taking over the task of propelling the rocket higher and faster, continuing the journey into space. This process can be repeated with multiple stages, each one providing an extra boost, ensuring the rocket reaches its intended altitude and speed. This staged approach reduces the overall weight of the rocket as it ascends, making it more efficient and capable of reaching higher altitudes. It allows the rocket to break through the upper atmosphere and enter space, achieving greater speeds and distances. The final stage carries the payload, which could be a satellite, a spacecraft, or even humans, to its final destination. This stage is responsible for placing the payload into its intended orbit or trajectory, ensuring it reaches its precise location in space. Each stage plays a crucial role in the success of a rocket launch, ensuring that the payload reaches its destination safely and efficiently. The coordination and timing of each stage are critical, and the success of the mission depends on the flawless execution of this intricate process. So, let's talk about reaching escape velocity. This is the speed that a rocket needs to break free from Earth's gravitational pull. It's a critical concept in rocket science. Now, you might wonder, how fast is this speed? Well, it's about 11 kilometers per second. That's over 25,000 miles per hour. Imagine that for a moment. To achieve this, rockets need to generate an immense amount of thrust. This is why they have multiple stages, each shedding weight and providing more power as they ascend. It's a complex process but absolutely fascinating, and remember, reaching escape velocity is just the beginning of a spacecraft's journey into the vast expanse of space. So, next time you see a rocket launch, you'll know just how incredible and challenging it is to reach that critical speed. So let's dive into what really powers these magnificent machines. At the heart of every rocket is a powerful engine, capable of producing immense thrust. This thrust is what propels the rocket upwards, defying the pull of gravity. It's a fascinating blend of chemistry and physics working together seamlessly. Now as we move forward, let's talk about how rockets have revolutionized space exploration. With advancements in technology, rockets have become more efficient, reliable, and capable of reaching farther destinations. This has opened up new frontiers for scientific research and, human exploration. The possibilities with rocket technology are, quite frankly, limitless. We're not just talking about reaching the moon or Mars. We're envisioning interstellar travel, the colonization of other planets, and, even mining asteroids for resources. The future is, indeed, brimming with potential. So, as we wrap up our journey through the basics of rocket science, it's clear that our quest to explore the cosmos is just beginning. Each launch, each mission, brings us one step closer to understanding the universe. And who knows what incredible discoveries await us just beyond the horizon.